Hello, everyone. Welcome to another episode of Echo Live. We're going to get started in just a second. So if you're just joining us, go ahead and write down your name. Tell us where you're tuning in from, and we'll be getting started momentarily. So I'll see you guys in just a second. Today, we will be exploring big impacts. Hello, welcome. I see we have a classroom tuning in from California. Welcome. I'm so glad you joined us today. We are going to be doing a special story time today. And that story is all about one of my favorite topics, asteroids. So that's what we're going to be learning about today. We are going to be learning about asteroids. We have a really fun story planned for you guys called Oh No, Astro. And we're also going to talk about sort of the future of space exploration and how it relates to asteroids. So one thing I'd like to do before we get started is have you guys share in the chat one of your favorite space facts. That'll just help me kind of gauge what you guys are interested in. And it's just fun to share things that we know about space. So for Mrs. Worst's class, if you can find some good suggestions and just type that into the chat, I would love to hear everyone's favorite space fact. Because space is super, super cool. You could spend your whole life learning about it. And perfect. So while I wait for those answers, I'm going to start a little tour of our solar system. So before we can talk about asteroids, we have to know about their home, where they live, which is our solar system. So we live in the universe in a cluster of stars and dust known as the Milky Way galaxy. And right in a tiny little corner of our galaxy is our celestial neighborhood, our solar system, which formed out of a spiraling dust cloud, cosmic dust cloud that condensed into a bright, burning ball of light, and that is our sun. So our sun is huge. In fact, pretty much everything that made up our solar system, all of that dust that was just floating around in space, is now our sun. So we have this giant, giant sun, and it's so powerful, so bright that the little clusters of dust that were still left afterwards were getting pulled in and started circling around the sun. That formed the planets. Now, there were 4 planets that were so close to the sun, all of their really lightweight gases got blown away by the early sun. And so there were just these hard, rocky materials left over. So we call those 4 planets the rocky planets. And we're going to take a look at them now. Each one has a name that we actually get from our ancestors going thousands of years back. When our ancestors looked up in the nighttime sky, they saw these weird little stars that seemed to move across the sky, which was weird because none of the other stars did that. So they thought these stars must be special. So they were named after different gods that were really important to those ancient cultures. And we still share those names today. Now, the first one is named after Mercury, a god who was a messenger or a delivery man. And so he moved really, really fast. And that makes sense because we have that planet right here. His name is Mercury, and you can see he's got his little sneakers on so he can move quickly. And he does move very, very fast around the sun. Now, Mercury isn't a god. Mercury is a small rocky planet that is very close to the sun, and it's the first one. So it hangs out very, very close to the sun. Next, we have a planet that's very, very beautiful. Sometimes you see it in the night sky. It's called the evening star. This planet formed close to the sun as well. So it's another rocky planet, and it's actually very close in size to Earth. It's Venus. It's Venus. And I see we're getting some responses. Ooh, a great question. So I'm just going to keep looking at those questions, and I'm going to work them into our program after we finish our tour of our home in the solar system. So Venus is very, very hot. She's very beautiful. She's named after the goddess of love and beauty, and it's so apparent why. Mwah! She's gorgeous, but she is also a terrifying planet. She is so hot. She has volcanoes. She is on fire. In fact, Venus is the hottest planet in the solar system because of its thick atmosphere. After Venus, we have my favorite planet, the planet Earth, who is very, very special. Earth is a great place to buy a house if you're looking. You know, it has everything you could need for a home. You have liquid water, which is important for life as we know it, in all three phases, solids, liquid, and gas. That's actually very important for life. So we're very lucky that we live on such a special planet that has everything that we need. Now, all of the planets have something called satellites that go around them. Now you might say, Julia, Mercury doesn't have a satellite. Venus doesn't have a satellite. Well, satellite can actually mean two things. There are two kinds of satellites. There are naturally occurring satellites, which we have another name for. We call them moons, just like our moon. And we also have satellites that are man-made. We have quite a few of them on Earth. NASA's actually planning on sending another satellite all the way to the moon for the Artemis program in preparation of sending humans back to the moon in 2024. So fingers crossed that everything keeps going great as it's been, and we will be back on the moon. Now, we call satellites we call something a satellite when it goes around something else. So if we have a moon that goes around the Earth, we call it a satellite. If we have a man-made machine that orbits another planet, whether that be the Earth or another planet in the solar system, we also call that a satellite. And then some of you may be sitting there and thinking to yourself, well, the Earth goes around the sun. Does that mean that the Earth is a satellite to the sun? Well, Mr. Smarty Pants, you're right. That's absolutely right. We determine what's a satellite in relation to another object. So you'll find that as we move in our tour, we're going to see even more satellites, and we're going to talk about that more. So moving on, we've seen Mercury, Venus, and Earth are the first of our 4 rocky planets that are very close to the sun and small in size. to finish those, we have Mars, who's so little. He's very, very little, has a little polar ice cap here. And Mars is the end of our inner planets, our 4 rocky planets. Next, we have to go a very far distance. We actually have to go 5 times further than the distance from the Earth to the Sun. We have to go 5 times that to get to Jupiter. So there's all this space between Jupiter and Mars. And in that space, there's something called the asteroid belt, which the solar system uses to hold up its pants. Just kidding. Wanted to see if you were still paying attention. No, the asteroid belt is where we find asteroids, and we'll come back to the asteroid belt. But continuing our tour, we are now in what's considered the outer solar system. This is where we find 4 very large planets known as the gas giants. They're very big because they were far away enough from the sun when the solar system was forming that they didn't lose all of their lightweight material, which now exists as atmosphere and, in some cases, ice. The first of those is Jupiter, which is the largest planet in the solar system and has many, many moons, moons that are the size of small planets. So Jupiter has many moons, as does the next planet in our journey, Saturn. Saturn actually has more moons or natural satellites than any other planet in the solar system, at least right now. There's kind of a competition going on between Jupiter and Saturn. We don't actually know for sure how many moons either planet has. We're constantly discovering more, and I don't see that stopping anytime soon. It's a very exciting time to be alive as we learn more about the solar system. Now, Saturn not only has a whole bunch of moons, but it also has a set of rings, which are actually made out of small, small particles of ice and dust. Now, moving on, we're in the distant reaches of the solar system now. We have Uranus, which is a planet that's tilted on its axis. What does that mean? Well, if we actually look at Saturn, we see that if we look at their rings, we see that Saturn's rings go around Saturn, which is also the way that Saturn spins. But Uranus doesn't spin, it rolls like a barrel. And this is actually one of the great mysteries of the solar system and another discovery waiting to be made. Now, the last planet in our trip is Neptune, which is the furthest away from Earth. It's around 40 times the distance of the Earth to the sun. It's so far away. And it also has quite a few moons. It also has some faint rings. In fact, Jupiter, Saturn, and Uranus all have these rings that go around them. It's just Saturn's is the most prominent. Now, close to the orbit of Neptune are 2 dwarf planets. We have Pluto and Charon, which are dwarf planets. They're bigger than an asteroid, but not quite planets. And then, of course, we have asteroids, which we can find throughout the solar system, but the majority of them we will find in our asteroid belt. So the asteroid belt is between Mars and Jupiter, and there are quite a few asteroids in that area. So an asteroid is just a collection of rock and dust that's kind of left over from the formation of the early solar system. And those asteroids haven't collided with other planets. They haven't been used as raw material for the formation of planets. So they're just kind of left over from the early solar system. Now, this is really great for scientists because that means they may hold clues to what the early solar system was like billions of years ago. Being able to visit an asteroid is kind of like being able to work as a detective and finding evidence that's left over from 5 billion years ago. How would you like to be able to see material that hasn't been touched from, and is still intact from its formation 5 billion years ago? So I have a fun story. It's super cute. It's called Oh No, Astro. And we're going to take a look at this story together. And then we're going to take a closer look at asteroids. But before we do that, I'm going to take a look at some of your comments. So Anthony was asking, why is a rock out of space a harder impact than a volcano? That is such a great question. So it has to do a lot of it has to do with speed. So we can use a little bit of mathematics is very simple to use, created by Isaac Newton. Isaac Newton's second law of motion, which describes how much force an object can exert on another, a way to calculate that force. And we know that mass times acceleration equals force. So that means that if you have a collection of mass, so say a large rock in space, the more you speed it up, the more force it's going to apply. And often an asteroid that's coming through space is going to gather a lot of speed. And we're actually going to see that in our story. So, someone asked, could you land on an asteroid? Yes, you can. Stay tuned. More information on that. All right, so we're going to take a look now at our story. Let's go ahead and we will go ahead and take a look at a story of an asteroid that gets knocked out of its orbit. Let's see. I just have to get oriented here. All right, are you guys ready? Today, we are going to read Oh No, Astro by Matt Roeser, illustrated by Brad Woodard. So first, we see stars and our Milky Way galaxy, which we know we live inside with our planets that go around the sun. And we see a satellite, a man-made satellite. And let's go ahead and begin. Everyone knows that asteroids are a rather rambunctious group. Well, most asteroids. All Astro wanted was for his personal outer space to be respected, as it had been for millions of years. Greetings, celestial wanderer, said Astro to an approaching satellite. Please keep your distance. You stay in your orbit and I'll stay in mine. It's one of the core rules of the cosmos, you know. And yet, you come closer. Good gravity! You've struck me. Astro was understandably distraught, but before he could point out to the satellite that it had done considerable damage to one of his favorite craters, he began to spin. Pluto's revenge! That rotating rogue seems to have knocked me off orbit. This is humiliating. Astro found himself in unknown territory. When an asteroid leaves its orbit, it hurtles through space on an unpredictable path, reaching unstoppable speeds. Why, I never! But he did. Hi, Mars! Bye, Mars! Meanwhile, an Earth girl named Nova was enjoying a quiet night of stargazing when something caught her eye. Ah! Pardon me! As Astro zoomed past the moon, he realized with a sudden clarity where and how his journey would end. I don't like confrontation! Astro began to break apart as he entered Earth's atmosphere. It tickles! And smash! Astro opened one eye, then the other. He was certainly smaller, but still in one piece. My stars, he muttered. Dare I say, that was fun. What on earth shall we do next? All right. So that was our story with Astro as he was traveling through the solar system and falling into the Earth. And as we saw, he gathered a lot of speed. He was going very, very quickly. And someone was asking, could you land on an asteroid? Absolutely. In fact, we saw in our story that a satellite touched down on Astro. This happened very, very recently. In fact, there have been 2 space probes that have touched down on asteroids. We certainly hope to send more. The first was sent by a Japanese spacecraft. The second was a NASA spacecraft that recently touched down. In fact, I have a video prepared just in case anyone was curious, talking about this mission that set foot on an asteroid called Asteroid Bennu. So let's go ahead and take a look at that. In just a moment, we will take a look at OSIRIS-REx, which was the name of the space mission through NASA. I know everyone's super excited. In fact, we can actually see OSIRIS touch down on this asteroid. Okay, and we're going to take a look at that in just a moment.
Over 200 million miles away from Earth, OSIRIS-REx is preparing for NASA's most ambitious sample return since the Apollo program. After months of detailed analysis of Bennu's terrain, the team selected the Nightingale crater as the sample site for the mission. OSIRIS-REx will need to carefully dodge rocky hazards as it descends to a space no larger than a few parking spots. This spacecraft has mapped the terrain in high resolution, capturing a stunning catalog of images across Bennu's rough surface. And now, we are ready to target Site Nightingale for the touch-and-go sampling event. OSIRIS-REx is prepared to begin its descent down to Bennu's surface and finally collect a sample. Using its database of images from Nightingale as a guide for its onboard navigation system, natural feature tracking, OSIRIS-REx will steer itself to the tag location, dodging Bennu's rocky hazards along the way. After years of preparation, analysis, and rehearsals, our target is in sight. OSIRIS-REx is ready to tag.
Okay, so I'm sure you guys saw that there was a date, October 20th. So that was the date that this touchdown actually occurred. And now what I'd like to share with you is video footage of that actual touchdown, which is very, very cool. So we're going to take a look at that now. So just sit back and relax and watch history in the making. So there we had our touchdown, and a very, very historic moment for all of us here on Earth, because that is the largest sample taken from an extraterrestrial body since the Apollo mission. So this is very, very exciting. There is a high probability that we will find platinum and gold on asteroids, which is very exciting because those substances are needed to create computers like the one that you are using to receive this transmission. And because of COVID-19 and social distancing, we have acquired a need for these materials that have been unprecedented in human history. And so now, thanks to the efforts of organizations like NASA and SpaceX, it's becoming viable for us to actually go to these asteroids and actually mine them for materials. So once again, it's a very exciting time to be alive, especially in terms of space exploration. Now, someone asked, if there is no oxygen in space, how do asteroids still fly down fast? That is a great question. Actually, oxygen is not great for moving quickly because oxygen creates resistance. So space is what we call a vacuum, which, as you know, means that there's no oxygen, there's no gases at all. So objects can move a lot faster in a vacuum because they're not facing any air resistance. They're not being slowed down by small particles of air or oxygen. Now, we have some really great questions here. Now, we saw in our story that Astro the asteroid was knocked over by a satellite, just like OSIRIS-REx from NASA, and then began hurtling towards the Earth. Do you think we have to worry about that with Bennu? No, no. The touchdown did not really affect Bennu's orbit at all. And we don't have to worry about Bennu crashing into the Earth. But that is how craters are formed. So have you ever been out? It's a clear night, you're outside, you look up and you see the moon and you think, wow, it's a full moon, it's beautiful, and you're looking at it. Maybe that's just me. But if you haven't, you should try it. It's great. Go outside, look at the moon. Maybe even take out a pair of binoculars and look at the moon, even with cheap binoculars or a cheap telescope, and you'll see craters all over the moon, indentations. And those are created by asteroids and comets slamming into the moon. In fact, every celestial body, from Neptune to our moon to Mercury, have these impacts. Asteroids hit planets, leave impacts, and if there's no atmosphere, if there's no oxygen, no gases, for example, like on our moon, then we can still see those craters. In fact, I have some pictures of a crater for you guys that I would be happy to show you. It's a very famous crater on the moon called the Tycho crater. All right. And it's a great crater to look at through a telescope, and you'll see the moon is covered in those craters. So I really recommend going out when there's a full moon, taking a look, and just looking at the craters and really appreciating the journey that the asteroids had to make to get there. So I'm going to be closing up, but I just want to take some time to take any questions. So go ahead and type up your questions. While you do so, I would like to thank Denso and Ford for generously supporting us. They are our lovely sponsors, letting us bring this science to you. And don't forget, you can catch us every Wednesday at 2:30. And so we'll just take a few more questions if you've got them. While we do that, there's just some cool stuff to keep an eye out for right now if you're out looking at the moon. Also, take a look at, when you go outside, when it's dark out, take a look directly above you. You'll see a very red looking star. That's actually the planet Mars. You can see it with your own eyes. If you look to the right of that, you will also see two very bright objects. Those are actually Saturn and Jupiter. Perfect. Now, I know Owen was asking, how does an asteroid create such an impact when it hits the Earth? The Earth's gravity pulls the asteroid into our atmosphere. That also adds to the asteroid's acceleration, again, creating a very powerful force. is a planet made of many chemicals. Ooh, more than I can even dream of. So many. And it can be very overwhelming. But there's a really wonderful tool that scientists use to make it a little less overwhelming, and that's the periodic table. So that's a great thing to look up and learn more about, because even though there are far too many chemicals in a planet for me to talk about right now, all of those chemicals are made of a basic collection of elements. So definitely check out the periodic table. It's super cool. All right, that's it. Thank you so much for joining me, friends. And remember, stay like Astro and be out of this world. Bye.